In this video, I'll cover how to select participants for your study, and once you've selected those participants, if you need to group them into different study groups, how can you go about assigning them into different groups? So the two big concepts I'll be talking about in this video are sampling or selection, so we can use those two terms interchangeably, and assignment. So sampling or selection deals with selecting people from the world at large to participate in a research study. So for example, I've read some articles involving men who have experienced a spinal cord injury while playing competitive rugby, and these were qualitative studies. So what I'm going to be talking about in this video can be applied to either qualitative or quantitative research. It's not specific just to quantitative research. But anyway, this is a very specific subpopulation of people. And I think basically what the researchers did was they contacted an organization that acted as a support system for these men who were once elite athletes, became injured, became paralyzed from that injury playing rugby. And they were able to find a database from this organization that allowed them to, reach out to these men to ask them if they'd be willing to participate in their qualitative study. So that's sampling. Assignment deals with assigning research participants into different study groups after you've already gone through the selection process. So for example, if you have 60 total participants and you'd like to assign 30 of them to a control group and 30 of them to an intervention group. So in this video, I'll be talking about different methods for doing sampling and assignment. So let's start with assignment. Let's say that you have already recruited 30 racket sport athletes for a study, and 10 of them are tennis players, 10 of them are table tennis players, 10 of them are badminton players, and you'd like to use simple random assignment to make two study groups. So we'll call group 1, or we'll call the control group Group 1, we'll call the experimental group Group 2, and in class we'll go over some different ways to use like random number generators to randomly split them into groups. Obviously I use this process using a computer app to group you all into different groups in class randomly and things like that, so it's pretty much the same idea. So we can begin randomly drawing them into either Group 1 or Group 2. It's essentially like just flipping a coin for each person, and in this case I am going to take some steps to make sure that the two groups have equal numbers, so 15 in each group. But what you'll notice is that I haven't taken any step to make sure that I have the same number of tennis players in each group, table tennis players in each group, badminton players in each group. So for example, you can see that there are 7 tennis players in Group 1 and only 3 tennis players in Group 2, and you'll notice if you happen to count, there's also imbalance in the number of table tennis and badminton players as well. But we could back up and we could do what's known as stratified assignment, where you're basically looking at each sport one at a time. And so if I start with tennis, I'm going to make sure that 5 of them go into Group 1, 5 of them go into Group 2, and then do the same thing with table tennis and with badminton. So again, that process is known as stratifying the sample, because I'm actually dividing them into sort of like subpopulations and making sure that they're evenly balanced. So for now, that's all I'm going to say about assignment. We'll talk more about assignment in class. For the rest of the video, I'll be talking mostly about sampling/selection. So some basic terms. The population is the whole group of possible subjects or elements to be studied. The sample is a subset of that population that has been selected to participate in the study. So just a visual of this, on the left-hand side, we see kind of the whole population, and on the right-hand side, we see the sample of 6 people, 4 men, 2 women, that have been selected through sampling to participate in this particular study. And then what's going to happen is the researcher will measure something about these people, examine them, maybe put them into an experimental setup, whatever, and collect data on them and use the results of that data analysis to gain findings that are going to be generalized back to the population of interest. So that's what's known as inference. And that act of generalizing is especially the motivation for quantitative research. And that's why in quantitative research, it's important to have a larger sample size, whereas in qualitative research, it's more of a motivation to look at a smaller number of individuals, not necessarily to generalize what you find out about those people to everyone else in the population. So on that note, how do you go about deciding how many subjects to participate in your study? So in qualitative research, as I've said, it's okay to have a smaller, more deliberately chosen sample. In quantitative research, it's usually an advantage to have a larger and, if possible, randomly selected sample and one that's representative of the population of interest. Does that mean that you should try to recruit as many people as possible? Well, yes, probably, but often we're limited by practical limitations, whether it's time, money, etc. We can only study so many people. But more often, the challenge for thesis projects and dissertation projects and independent study projects is, do I have enough participants? And in statistics, we can use what's called a power analysis to help determine the minimum number of people that we'd like to recruit to ensure that if there's an interesting finding, that your analysis is going to have the power to detect that interesting finding. So it's important that you have enough participants in your study. And the power analysis will vary depending on what statistical analysis you're going to do. So I'm not going to go into a lot of detail here, but just be familiar with that term, that's what a power analysis does. It helps you determine the minimum sample size. Sampling can be random or non-random. In random sampling, everyone in the population has equal probability of being selected for the sample. So that means you basically have an exhaustive list of every single person that's in the population, and you're going to use some random drawing to determine who's going to be selected for the sample. Although this is ideal, especially for quantitative research, in practice, it's usually difficult and possibly even impossible to do. So often researchers will use some form of non-random sampling instead. Non-random sampling is simply defined as not everyone in the population is equally likely to be selected. Here you see listed some specific types of random sampling and non-random sampling. And in the next few slides, I'll talk about random sampling. So for now, I'll cover non-random sampling. So convenience samples are samples of participants that the researcher has convenient access to. So for example, if the researcher works at a college, they might conveniently sample students at that college or athletes at that college, etc. Intact groups refers to groups or organizations that are already existing. So for example, you might choose a sports team to participate in your study. You might observe intact classrooms of students. So those would be intact group samples. Volunteer samples refers to situations where you basically advertise your study, and we see this a lot in survey research, where you try and send your survey out to as many people as possible, and you get people to volunteer to participate in your study. So you could put up flyers, you could put advertisements on social media, you could you put something in the newspaper or something like that, and basically get people to contact you volunteering to participate in your study. So now I'll talk about the different types of random sampling using the following example. So let's say we want to examine the population, all students attending community colleges in Massachusetts. So if we Google this, we'll find that there are approximately 156,000 community college students currently in Massachusetts. So let me talk about simple random sampling, systematic random sampling, and stratified random sampling, and how that would apply in this example. So if we use simple random sampling, we basically create an entire list of all 156,000 community college students in Massachusetts, and we would use some type of random number generator, basically randomly draw names from that list, just kind of in random order, randomly draw. Let's say we want 100 people, so we draw 100 names. With systematic random sampling, you would basically start with that list, and let's say you randomly choose a starting point, like the 45th person. So you choose person number 45, and then you just go every 1,000th name after that. So if person number 45, person number 1,045, 2,045, 3,045, etc. So there's a systematic way that you're choosing names off the list after you've picked a random place to start on that list. With stratified random sampling, you're dividing your population into different subcategories before you start sampling and making sure that you have certain representation from each of those categories. So you might do this with gender. So you stratify your sample into men and women, and then you randomly select a certain number of men and a certain number of women. Or you could you could stratify by age groups or race categories. Lots of different ways you could stratify and then sample from those categories. Now I'll talk about cluster sampling and multi-stage sampling. So the clusters in this example are the different colleges. So instead of sampling the individuals, I could sample the clusters randomly. So let's say I want to pick 6 clusters: Northern Essex, Springfield Technical, Bunker Hill, Mount Wachusett, Bristol, and North Shore. So I've randomly chosen these 6, and now all students who go to these colleges are going to be asked to participate in my study. In multi-stage sampling, you basically take it this far, and then you go one step further, where now I'm going to randomly sample individuals from each of these clusters. So in cluster sampling, you sample the clusters and you include everyone who's in those clusters. And in multi-stage sampling, you sample the clusters and then you also sample individuals from those clusters. So maybe I only want 20 participants from each of these 6 colleges for a total of 120 participants. That would be multi-stage sampling. And that's all for selection, sampling, and assignment. And we'll talk more in class about especially random assignment. Thanks, and have a good day.